Okay, so there's a couple other ways we can solve quadratics, and the other two ways involve using a graphing calculator. So solving quadratics using a graphing calculator. The first thing we can do is use tables. So we can look at a table of values. So we have y equals x squared plus 5x plus 1. And what I've done here is I've made a table of values from, I just pulled it up on the graphing calculator and then transferred it over here. So notice right here, from 5 to -4 in the x direction, our y values go from positive to negative. And down here between -1 and 0, our y values go from negative to positive. So hopefully it kind of makes sense that if we have a y value as we cross the x-axis, that if it must be negative down here and positive up here. So if we see that change in sign, we know there must be a 0 somewhere in between these two x values. Okay, so what we can do is change the step value to narrow in on these zeros. Okay, so I have some screenshots here for you. Hopefully you can see them okay. So what I've done is, here is my table of values. So to do that, we go Menu, Table, Split Screen Table. And it brings up our table of values. Okay, so from there, what we want to do, because remember this, this table of values is not what's going to come up right away. So what we need to do is change some settings. So we need to go into the menu and the table and edit table settings. And we want to change our table start to -5. We want to start here, have -5 at the top of our chart. Okay, and since neither one of these are really close to 0, I'm going to change my table step so that it's a little bit smaller. So instead of having a difference of 1 for each x value, it's going to be a little smaller. So I'm going to change the table step to 0.25. And notice here when we do that, now from -5, we're at 1, and now we have -4.75, and we're down at -1.875. So we're a lot closer to finding where that 0 is. So from there, I'm going to do that one more time. I'm going to change the table step to 0.1. And notice here, when we do that, it's still positive at -4.9, still positive at -4.8, but look how close it is to 0 there. It's 0.04. So it's 0.04. That's really close to 0. And then when we get to -4.7, our y value is negative. So notice here we've narrowed down. Now we know our 0 is somewhere between -4.7 and -4.8. So it's a lot more precise now. If I were to make a guess, or to just say if we were to round to the tenths, this would be our answer, x equals -4.8. Okay, but if we had to round more, we could change this table value even more to maybe 0.001, and that might help us narrow in even closer. Okay, so we want to do that same thing for our other 0. So we scroll down to x equals 0. And because remember here, it was between 0 and -1. So scroll down to where 0 is on the bottom. And notice here, our 0 is somewhere between, here it's negative at -0.3, and here it's positive at -0.2. So our 0 is somewhere between -0.2 and -0.3. Okay, so if we needed to make a close estimation of what the 0 is, we could use tables to do that. Okay, so next, we can also find zeros from the graph directly. So in the menu, so if you have your function graphed, in the menu, go to Analyze Graph, and then from there you want to find zeros. So I've kind of shown you here, here is the menu, go down to Analyze Graph, and the very first one is zeros. And what happens when you do that is, and I'll show you more on how to do this in class, but we highlight where that 0 is, and it tells us that the 0 is at negative 4.79. So we found where exactly that value is at negative 4.79. This might be rounded just a little bit, so I shouldn't say exactly, but it's about negative 4.79. And if we do that same thing, we would find our other 0 is at negative 2.09, or 0.209, sorry. So negative 0.209 is our other 0. So we can use our graphing calculator to find these zeros really easily as well. Okay, so that's all I have for you today. We'll work more with the graphing calculator in class. So be prepared for that. Thank you for watching, and once again, I hope to see you again soon.